In part one of this lab, you're going to explore two reactions. One of the reactions is solid copper, which is what I have in my well tray right now. And in a little bit, I'll add some zinc 2+ to the copper. Conversely, we have a second reaction that's the reverse reaction of what we're looking for when we interact copper and zinc 2+. So in this well, I have a little bit of zinc solid, and to that zinc solid, I will be adding some copper 2+. What could happen in either of these cases is you may or you may not see a reaction depending upon whether or not the reaction is spontaneous. So for the first reaction, I'm going to take 0.1 molar zinc sulfate, and I'm going to add a couple of drops of zinc sulfate to copper. And you'll notice in this case, we can zoom in a little bit more. Nothing is really happening right now. We'll come back to it in a little bit, see if any reactions did take place. Next time, I'm gonna grab some 0.1 molar copper 2 sulfate, and I'm gonna add the copper 2 sulfate to the zinc metal. So if you're watching closely, what you'll notice is we started with zinc that was a nice silvery zinc color, and almost immediately in solution you start to see the zinc metal being coated with this dark coating. The dark coating is the copper 2+ that is reacting and forming copper solid on the zinc particle. From here, you're going to work backwards work forwards in your worksheet. You're going to look to see can you write the redox reaction for the spontaneous reaction, recognizing that the reverse reaction is considered non-spontaneous. In part 2, we're going to do what we did in part 1, but expand it to look at 4 different metals and 6 different cations. I've got the first 3 cations set up with their respective metals. So we have left over from part 1, the copper mixed with zinc 2+, where we did not observe a reaction, versus zinc with copper 2+, where we did observe a reaction. So in the rest of these wells, I have zinc when we want to react it with tin, copper to react with tin. I've left these 3 wells empty because they would just be mixing the metal with its own cation. I have tin in the 3rd set of wells, and I have iron in the 4th set of wells. Just like I did in part 1, I'm going to add the cation solutions to each of the metals, and we'll observe what happens. So we'll start with the zinc 2+, and we'll add some zinc 2+ to the tin. And the immediate result is it does not appear to be any reaction taking place, but we can revisit that later. And then with the iron, we add the zinc to the iron. And again, it disperses out the particles a little bit more. I can zoom in on that area for you, but you're not seeing a big change in what's happening. It's simply the solution with the solid inside of it, no reaction. So I'll zoom back out, and we can then look at what's happening when we add copper 2+ to the tin and copper 2+ when it's added to iron. You'll notice when we're looking at this, the tin metal is a little bit larger in size than the iron dust particles. It's just a difference of size. In some cases, the larger metals might take a little bit longer to react, so we'll come back to these plates at the end to see if we missed anything. So we're going to add some copper 2+ to tin. I'll add 2 drops. Again, the initial observation appears to be nothing reacting. You can still see the shiny metal. For the next reaction, we're going to add copper 2+ to the iron. And let me zoom in so you can see what's happening. The initial observation is there doesn't appear to be a lot happening, but again, we'll go back to that one in a while and see if we see any changes occurring. Okay, so we've done the first 2 rows. You should make sure you've recorded your observations in your table for what happened when zinc 2 plus was added to the different metals or when copper 2 plus was added to the metals. Now we're going to move forward and look to see what happens when we add tin 2 plus to the different metals. However, before I continue, I want to zoom in a little bit more one more time on the iron so that you see what's happening here. In this particular situation, I'm starting to see a difference in color. So if you compare the color of the iron when we added zinc 2 plus to it versus the color of the iron when we added copper 2 plus to it, you'll notice that this is not the difference in the camera lens. You're actually starting to see some of that copper color precipitate out. That's a suggestion that the copper 2 plus is reacting with the iron. All right, now that we caught that reaction taking place, we can move forward with our tin 2 plus. We're gonna have a 0.1 molar tin 2 chloride added to each of these metals. So I started by adding some tin 2 plus to the zinc, and as we zoom in, you'll see anywhere where the solution is on top of the metal zinc that it's starting to form this gray precipitate. You also see a bit of bubbling happening. It turns out that to make the tin 2 plus soluble, I had to add some acid to that solution. So the bubbling is a function of the acid, not a function of the reaction of the zinc 2 plus reacting with the, the tin 2 plus reacting with the zinc. So certainly this is an example of a reaction taking place with the zinc. Okay, so we can move on to our next reaction of copper with tin 2 plus. So we've added our tin 2 plus to the copper. For the time being, it appears that all we really see is the copper metal in solution. So for the time being, we will say that's no reaction. Finally, we'll look at the iron, where we add tin 2 plus to it. When we add tin 2 plus to the iron, we'll look to see what's happening there. So in this case, we've got to look closely, and it, at first observation, does not appear to have any reaction. While we're zoomed in, I want to go back to the copper 2 plus, where you have copper 2 plus added to the tin. So this cell right here, copper 2 plus plus tin metal. You'll notice that compared to what we saw up here where zinc 2 plus was added to tin, now we're starting to see a darkening of some of the grains. Again, because the tin is a larger particulate, it's a bit of a slower reaction, but we do see some reactions of some copper starting to turn into copper metal on the surface of the tin. So on final glance, not much of a reaction, not much of a reaction, not much of a reaction, definitely a reaction, a bit of reaction, copper precipitating here, a big reaction here, not much of a reaction here, and then not much of a reaction here, although that one's a little bit harder to see. So in the next video, we'll go through the next 3 cations that we're going to analyze. For the next set of reactions, we're going to be adding lead 2 plus, silver 1 plus, or magnesium 2 plus to the 4 different metals. This time around, there's no duplicates of metal with metal cation, so we'll have all of the wells open with data to record. So I'm going to start out with some lead 2 nitrate, and I'm going to add it to each of the metals. So now that I've added all of those, I'm going to zoom in a little bit. Certainly you can see the shiny appearance of the zinc starting to disappear as the lead begins to form a solid. When it comes to the copper, it doesn't look like there's much of a reaction initially. When we look at the tin, we're not seeing much of a reaction initially. And then when it comes to the iron, again, the iron particulates are a little bit more difficult to see, but my initial instinct is to say there's no reaction there. We will again go back to it later on and see if we see any changes over time. But certainly of the four, that's the most reactive. So now that we've done lead 2+, we're going to move on to adding some silver nitrate. You'll notice that silver is the only cation that we're adding that has a +1 charge. So we're going to go through and carefully add the silver to each of these species. Silver is very reactive. Silver 1+ is very reactive, can stain your hands black if you were to touch it. So I put some gloves on for this. I'm going to go through one at a time and add a drop or two of silver 1+ to each of the metals. All right, as we look at these, we'll take note of what is happening. We'll start with the zinc. The zinc, like we've seen with some other examples, immediately starts to turn this black color as a reaction begins to take place. When we move over to the copper, if we contrast that with the copper that was mixed with lead 2+, now the copper that's mixed with silver 1+ never looks like it has that copper color anymore. A precipitate is definitely forming there. When we look at the tin with silver 2+, again, contrasting that with the previous example, you're starting to see this black coloration forming. And then finally, when we move on to the iron, unlike some other examples where it was hard to tell whether or not something happened, here we see big black blobs forming in this solution as the silver is precipitating to silver metal. Okay, so that was a pretty exciting set of rows to look at. We'll now move on to our last cation. Our last cation is going to be magnesium. So we're going to find some magnesium sulfate, 0.1 molar. Magnesium is a 2+. I'm going to add about 2 drops to each of these setups. All right, so we'll zoom in one last time and talk about these one at a time. The magnesium reacted with tin. Doesn't really appear like it has much of a reaction. The magnesium 2+ with copper doesn't appear to have much of a reaction. The magnesium 2+ when reacted with tin doesn't appear to have much of a reaction. And the magnesium when it's mixed with iron doesn't appear to have much of a reaction. So we can stand back for a moment, forgive my tripod, and look at all of our reactions all at once. Yeah, now what you're gonna have to do is sort of tie all of these observations together to figure out which types of half reactions are more reactive than others, which of the metals is the strongest reducing agent, which of the cations from the 6 that you had to choose from was the strongest oxidizing agent, and we'll compare that with the literature value and some numerical values for electrochemical cells from part 3.